Oh, why does Python feel slower than C? Is it because of interpreters or something deeper? So let's break down how your code actually runs. So there is some assumption in this. So what is that means? CPU can able to understand only machine code, that is a binary code only. That is, it can able to understand either zeros or ones. But we write the high level code. So whatever the program that we are writing, that is a high level code. So the machine cannot able to understand high level code. It can able to understand only low level code, that is machine code. So so here you can see how we are converting the human code to machine instructions. So it means here we must able to convert this measure here we must able to convert this low level high level code to low level code. It means the machine which can able to understand, we have to convert into that code. So that is what. So here you can see from human code to machine instructions. It means what it is saying means, so for every computer, so for every computer, there is some fundamental truth. It means whatever the code that we are giving, whatever the program that we are giving, so inside that there are some processors. That means there are some machines which can able to understand the code. So it means you are thinking that, so whenever we write some logic, it is directly understandable by the machine, but that is wrong. So there is something happening internally. So what it is means, so whenever you write some code, so that code will be taken by the compiler, and then it will be converted into the low level code. It means it converts each and every word into the zero binary form, that is zeros or ones. So after converting into binary form only, it will able to understand what you have written. Then then it will produce the output for that. So that is what happening in the internally. So this is the binary language. So it is incredibly difficult for humans to work with directly. It means if you want to convert what we are writing, that whatever we are doing the coding, in order to convert that our high level code into the zeros and ones, it is very difficult to make it. Why? Because means uh, for a single line or two lines of code we can able to convert. But if we write some thousands of code, how can it possible? It is not possible. So it is only possible with the machine only. So that is what it is saying. So so here what we are doing means we are converting the low level code, high level code to low level code. So at the core, computers only can understand zeros and ones only. So every program, whatever we write, it must be translated before the execution. So before the execution only, every program will be translated into these zeros and ones. After changing into zeros and ones only, the execution will be started. So that is. So now we will see the compiler versus interpreter. So what is this compiler and interpreter will do means, so compiler is used by this C programming language and interpreter is used by this Python programming language. Now we will see the two parts of how their executions are working. So if you take the compiler, it will translate the entire program before the execution only. So before executing your code, it will translate entire program before the execution. Then after that, it produces the executable file. So if you consider the interpreter, what this interpreter will do means it will execute line by line. So whereas compiler, it will take entire program and then only it will execute entire program at a time. But interpreter is not like that. It will execute line by line. So even if there is a single error in a line, it will stop there and fail to it will fail to get the output. But in compiler, so it will take the entire code. Then only after taking entire code only, then it will start the execution. So if there is any error, it will show after the execution only. But in terms of interpreter, it will show before the execution also. If there is, suppose if you are executing four lines of code, If you are having any error on the second line, then it will stop there and it will show an error in such a way that you can able to modify the code during the runtime. So that is what. So what is the analogy behind this compiler means it will translate the full book. So it means if you are having an entire book, so what it will do, it will translate an entire book from one language to another language without reading any it. Once it is translated, readers who are there, they can able to access it fastly without waiting. But in coming to interpreter, what it will do means it is a live translator. Live translator means whenever you are trying to speak sentence by sentence, during that conversation only, it will modify everything. It means whether there are any errors or like that. So during the live only, it will able to understand and it will say there are errors like that. So this translation will happen in real time as we required. And also and also what are the pros and consequences for this compiler means, so if you see the pros, so compiler is a very fast as compared to interpreted. Compiler's execution is very fast compared to interpreter, so it is but interpreter execution is very slow. And also it will able to in compiler there will be an early error detection. It means we can able to detect the error very easily. And now we will see the consequences. This is platform dependent. Compiler is platform dependent. It means it depends on various platforms. If you take the C programming code and if you try to execute in code blocks, it will give the output. If you take the same code and if you try to execute on some other platforms, it may not give, it may or may not give the output. Sometimes it will throw an error. So that's why it is a platform dependent. It will uh, it will act according to the platform only. And also there is a longer initial translation time. So what is it means, so it will take much amount of time in order to translate the high level code into the low level code. So that are the consequences of the compiler. If you see the pros of the interpreter, so first one is platform independent. Platform independent is nothing but if you take any code and if you execute in any platform, it will run the code and it will produce a same output. So that's why it is platform independent. And also next one is easier debugging. It means if you are having any lines of code also, we can able to debug them easily. And also there is a faster development cycle. So that is what. So what are the consequences of this means? So slower execution. It means it takes more time to execute the program than compiler. Next one is errors found during runtime. So it means whenever you are running some program, during that runtime only you can able to find the errors. So whenever you find such a kind of errors during the runtime, you can able to modify it. But in compiler, you cannot able to modify the errors during the runtime. So that is what the pros and consequences. And also this Python is not purely interpreted. Why? Because means during execution also there are uh, there are two phases, that is compilation source code and next one is bytecode source code. It means here what is happening means Python will first compile our code into the bytecode. Then after that there is a virtual machine inside it. So the virtual machine will execute line by line. It means here both the compilation phase and interpretation phase are both are happening here. So that's why it is not purely interpreted. It is compile. It is both compiled and interpreted. So that is what. So now, now if you see the complete execution pipeline, now we will see the complete execution pipeline. So this is the complete execution pipeline of the program. Now see, so first source code. It means here whatever the program that we are writing, um, that will be the source code. So this source code will be giving to the lexical analysis. So lexical analysis means what do the lexical analysis will do? It will break our code into small parts. So whatever the sentences or whatever the code that is there, every code or every sentence is breaking into small parts. Those are called tokens. We can also call keywords, operators, identifiers, literals like that. So after breaking it to the token, it will pass. It means whatever the tokens that are there, those will be organized into the abstract syntax tree. It means it will create a syntax tree so that it will represent the hierarchical structure, and also it will represent the relationship in your code. So after parsing your tokens, then it will come. There is a bytecode compilation. So what this bytecode compilation will do? So here you are having abstract syntax tree, no? So it is compiled into the bytecode. It means a low level instruction is there, no? That will be saved in PyCache, or otherwise we call it as .pyvc files. For what purpose? Means for faster re-execution. So that is what. After byte compilation, it is coming into the PVM execution. PVM means Python Virtual Machine. So what this PVM will do, it will interpret the bytecode line by line. It means after bytecode compilation phase only, then our Python Virtual Machine is interpreting line by line. It means checking line by line only. Then after that, it will change it into machine instructions. So after interpreting the bytecode line by line, then we are changing that code into the mission instructions for which is required for our CPU. So after compilation phase only, it is taking the interpretation phase. So it means here both compilation and interpretation are happening here. So that's why it is not a pure pure interpreter. So that is what. And also bytecode is very important. So why? Because means it is the intermediate representation between the human code and machine code. So what it will do means, um, as we have seen. So what are the properties? Means it is a platform independent and it is stored as .pvc, and also it will perform the execution. It will improve the performance of this. So this is what the execution flow. Now, if you try to see the visualizing the process, how it occurs means, so first source code will be done. So after taking this source code, the compiler will compile it. Then after that, there will be some object versus linker. Then after it will go to the machine code. So after going into the machine code, then what will happen? It will convert the high level code into the low level code. Then it will start the execution by line by line. So that is what. See here, first source code. Next it will be converted into the tokenizer. Then we will be passing those tokenizers. Then after getting the abstract syntax tree, we will be compiling it into the bytecode. Then after that, we are giving it for the Python virtual machine interpreter. So what it will do? So it will it will run the code line by line. So this is what. Now see the key takeaways. So your bytecode is crucial. Now only I have said. One is platform independence. Next one is performance optimization. For if you want to optimize your model, if you want to optimize the code performance, then this is very important. So if you see beyond C Python, other implementations are also there. That is PyPy, the next one Jython, next one Iran Python. So like that, this will be the other implementations also there. Now we will see this compiler versus interpretation in Python's context. So if you first consider this compiler, what it will do, it will translate the source code into the intermediate code. And what this intermediate, if you see this interpreter, it will execute the bytecode by translating into machine code. That is what. And when the compiler will do, it will translate before the runtime, and when it will translate means during the runtime for every execution. And if you see the output, The compiler is platform independent bytecode. It means this bytecode is dependent on other platforms also. But in coming to interpreter, the actual program execution and results only. And speed. So in terms of speed, compiler is very fast in execution. But in coming to interpreter, it is very slow in execution as it takes line to line execution. And if you in error detection, if you consider the compiler, it will catch a syntax errors clearly early. So if there are any syntax errors, then this compiler will catch them earlier only before execution, before the beginning of the execution only, it will catch them. But if you consider the interpreter, the runtime errors discovered during the execution. It means whenever you are executing the code, during that runtime, we are discovering the errors. We are finding the errors. So that is what. If you take the memory, so compiler will store bytecode for reuse, but interpreter will execute instructions immediately. So whatever the instructions that we are giving, so immediately it will try to execute. So that is what. So finally, Python combines the best of the both worlds. Compilation for it will combine compilation. It is for efficiency and interpretation for flexibility. So that is what. So in conclusion, so that is what I want to say. So, and also in conclusion, if you see, Python's execution model combines, yes. So the Python will execute, will combine both the compilation step and interpretation in a hybrid manner. So in such a way that what will happen means whenever you are using this compilation, this compilation is for efficiency, and why we are using this interpretation means it is for flexibility. Next one means portability first. It means whatever the bytecode that we are having, we have to ensure our code run it anywhere. So it means the code should run in any platform. So we have to ensure that. So that is, and also it is developer friendly. It means we can able to develop the cycles very fastly. We can able to do the debugging easily, and also we will get immediate feedback for rapid prototyping. And also there is a performance balance as the execution speeds combines both with opportunities through bytecode caching and JIT alternatives. So like that, the Python will Python will balance the performance. So that is what. So this is what I want to say. So as we have seen everything, so from the next video onwards, we will be entering into the coding part. So up to now we have seen theoretical part. Next video onwards, we will be entering into the new topic, that is variables. Then we will start the coding from there only. So